such molecules. For the first one, I'm going to talk about ninhydrin reaction. Ninhydrin reaction, which is the most important reaction and reagent to determine whether is there any amino acid in a solution or not. So, to find out whether amino acid exists in a solution or not, we use such reaction, ninhydrin. Ninhydrin reacts with alpha amino groups in primary amino acid. The color which produce is Roheman purple. The name of color that is produced is Roheman purple. The intensity, the density of the color which is produced, I mean the density of purple which is produced, depends on the value, the concentration of amino acid in that solution. For example, if the concentration of amino acid higher in a solution, therefore the density, the intensity of those color will be higher. Please take a look at the post. As you can see here, we have two reactions for amino acids. The first one is for most of amino acids, which produce those colors that I mentioned. However, for proline, we have another color, just for proline. Just for proline. If you remember, I told you that we have two amino acids with different properties, characteristics against other amino acids. What are those amino acids?
Proline
and
glycine.
Glycine. Very good. Proline and glycine. Proline produce yellow-orange product. This is yellow-orange. However, for other amino acids, they produce purple-like color. They produce purple-like. Just for proline, they produce such color. No.
Doctor, can we turn off the light?
You can't see.
There's a
Yes. Any question? Another reaction is the carboxylation. The carboxylation, which means removing COO from amino acid. If you remember the shape of amino acid, all amino acid has a alpha carbon group with 4 atoms. The first one attached to COO, the next attached to NH3, one arm attached to H, and one arm attached to R group. In the carboxylation, the amino acid missed their COO group. So, enamine will produce. Enamine will produce. As you can see in this slide. The COO remove and amine will produce. This reaction is catalyzed by enzyme in our body, in our cell. The enzyme which catalyze this reaction named decarboxylase. Decarboxylase. The word DE before this name means that this enzyme remove. DE means remove. COO from ammonia. You can see here some example. One more thing. This enzyme needs a coenzyme for the reaction. This coenzyme is vitamin B6 or pyridoxal. Vitamin B6 or pyridoxal. We name vitamin B6 as pyridoxal or pyridoxal phosphate. So the carboxylases need B6 vitamin for their reaction. They need this vitamin for their reaction. I will explain more about such molecules, coenzymes, in our next session. You can see here some examples. For example, there are some important decarboxylated amino acids. The first one is dehydroxyphenylalanine. A molecule in the phenylalanine metabolism pathway. Another one, dopamine, epinephrine, very important neurotransmitter produced from phenylalanine and tyrosine. And as you can see them, there is no COO in these molecules. There is no COO in these molecules. So we give you 4 examples for decarboxylated molecules, decarboxylated amino acids. Okay? 4 examples for decarboxylated amino acids. Another reaction is deamination. As I said, DE means remove amine group. So this reaction is catalyzed by an enzyme named deaminase. Deaminase. The enzyme that catalyzes such reaction named deaminase, which means enzyme which removes amine group, just amine group. You can see here an example. Okay. Both decarboxylation and deamination will happen mainly in liver. Especially for deamination, this reaction will happen in your liver. Okay. We will learn that about just one amino acid, glutamate or glutamine. Is there any marker? No. Glutamate or glutamine, 2 amino acids. These amino acids can further deaminated in the kidney, just for glutamine and glutamate. Just for 2 amino acids. Glutamate and this. Read this name. Read these names. Just for 2 amino acids, glutamine and glutamine, the deamination reaction can happen also in kidney. Just for these 2 amino acids. I will let you know why just for this two amino acid this such reaction will happen also in kidney. We have not another example for deamination in kidney, just for two amino acids, glutamine. And glutamine can also be deaminated in the kidney. So please write these pictures. And about this image, as you can see at the image, when amine group will remove, when the amine group will be removed, please, ammonia will produce, which is a very toxic to our cells, and turn to urea in our liver, which is not a non-toxic to cells and exerted in urine. So, if I ask you, what is the exertion product of protein or amino acid, you can tell me that this is urea. So, proteins will be removed from our body as urea. Proteins will be removed from our body as urea. Don't you understand? Very good. All amino acids have two parts. One part is amine group, the other one is non-amine group. I mean the carbon group. The amine group in our body turn to ammonia. When removed from this reaction, by this reaction deamination, this amine group produce NH3 or ammonia. NH3. Ammonia is very toxic to our cells, especially for our nervous system. Ammonia is very toxic for our cells, especially for our nervous system. So, these molecules should turn to a non-toxic molecule, which is urea. Urea produced in our liver. Urea produced in our liver. So the question is, what is the exerted molecules of amino acids, or what is the exertion form of amino acids, or what is the waste form of amino acids, and that is urea. What about the other parts? The other part is a carbon skeleton, which can produce glucose, can produce acetyl-CoA, can produce ketone bodies. I will explain what are ketone bodies, acetyl-CoA, and so on. So please don't hurry, and we will know about these molecules.
Doctor, urea is produced in liver or kidney?
Produced in liver. Yes. The amination reaction can be happen for just two molecules of amino acids in kidney, and those are glutamate and glutamine. These two molecules. Other deamination reaction will happen in our liver and produce urea. Deamination reaction in kidney will not lead to produce urea. This reaction just produce NH3 and no urea will produce from this reaction in our kidney. Well, when two or more amino acids accumulate to each other, join to each other, link to each other, peptides are produced. So, peptides are the accumulation form of several amino acids. Some amino acids. Peptides are short chain of amino acids. How much? Up to 15. Maximum number of amino acid and maximum number of amino acid in the peptides are 15. 15. What is the importance of peptides in our body? Some peptides are hormones. For example, TRH, tyrotropin releasing hormone. Can anybody know or explain what is TRH? TRH is a hormone. The thyroid which stimulate TSH. TSH. We have a axis. We have an axis named hypothalamus, hypophyse, thyroid. We have TRH in hypothalamus, which stimulate TSH in hypophyse, and TSH impact on our thyroid and release and stimulate this gland to produce T3 and T4 or thyroxine. T3 and T4 or thyroxine. Another hormone which is a peptide is insulin. There are some other molecules, some other important molecules. Glutathione. Any idea about glutathione? Do you know what is glutathione? Okay, this molecule, glutathione. Glutathione, as you can see here, and please write, produced from 3 amino acids. 3 amino acids. The first one is glutamic acid or glutamate. Glutamic acid. The first one. So glutathione, this molecule. Glutathione produced from 3 amino acids. The first one is glutamate or glutamic acid. The next is cysteine, and the last is glycine. Well, glutathione produced by our liver. There are too many molecules will produce in our liver. Liver is the most important organ in biochemistry. We named it our factory. Liver in biochemistry is the factory of our body. It's the most important organ in our body. So there are too many molecules which produce in our liver. Glutathione involved in many processes in our body. For example, this molecule involved in tissue welding and repairing. We can write this explanation functions of glutathione. One function of glutathione is tissue welding and repairing. The other one is making molecules and chemicals. Making too many molecules and chemicals for need for our body. And the last one is immune system function. There are some other peptides in our body. Another example. For example, antibiotics and anti-tumor molecules are peptides. Some examples: actinomycin, bacitracin, colistin, polymyxin B. There are some examples of antibiotics or anti-tumors which have a peptide-like shape, peptide-like structure. So there are 1, 2, 3, 4 examples for antibiotics and anti-tumors which are peptides. Peptide antibiotics and anti-tumors like these molecules. And finally, when more than 15 amino acids accumulate, join to each other, we have proteins. More than 15, we have proteins. Proteins have too many functions. These molecules are the most important molecules in our body. For example, there are some proteins which are involved in transportation, like albumin, very important protein in our body, which is produced in our liver. There are two important sites for producing proteins. The first one is our liver. Proteins are produced mainly in two places. The first one is our liver. More than maybe 80%. The next one is our immune system. I mean B lymphocyte. Can someone tell me what are lymphocytes? What are lymphocytes?
Yes,
The-
sure, they are cells.
Yes, it's like a nurse in the neck and the other places.
Organ of immune system.
There are several cells in our immune system which name white blood cells. White blood cells. One type of white blood cells are lymphocytes. Lymphocyte divided to two classes, two main classes. The first one is T lymphocyte and the next is B lymphocytes. T lymphocytes further divided to several classes. For example, we have T helper, T helpers. T helper cells are those cells that are impacted on the HIV AIDS disease. I mean, HIV virus can only enter to these cells, T helpers. We have also B lymphocytes. B lymphocytes are the other main cells in our immune system and produce antibodies. We have 5 types of antibodies or immunoglobulin. Immunoglobulin or immunoglobulins. IgA, IgG, IgM, IgD, and IgE. 5 main immunoglobulins in our body, which are produced by B lymphocytes. And all of them are proteins. All these molecules are proteins. For example, IgG is found in mother milk when she feeds her child. IgM is the first immunoglobulin antibody which produced in the first step of any infection. For example, Dana, he's beside it. When you suffer to, for example, hepatitis, to flu, the first immunoglobulin against this virus is IgM. Then, after 1 or 2 weeks, IgG will produce against those infections. So, the primary infection is responded by IgM, and the second response for infection is IgG. Both IgM and IgG fight against all diseases, especially infections. However, the first step will be IgM, and the late response will be IgG. Another important protein, albumin. Albumin I can say that albumin is the most important protein in our body because there are too many functions for these proteins. For example, albumin transport other molecules like calcium, like drugs, like fats, and too many other things. And also, albumin has the highest concentration in our body. The total number of proteins in our body is about 5.5 to 8 gram per ml. Gram per milliliter. Total number of protein in our blood. Around 3 to 8 to 5 gram per ml of these proteins is albumin. We have also other proteins, for example, rhodopsin, GI, UT. There are some transporter proteins. Proteins are have structural and mechanical function. For example, actin, myosin, troponin has a structural or mechanical function in our body. Can anyone tell me that what is the most important C for troponin? Troponin. What is troponin? What is the importance of troponin? Okay, very good. Troponin is the main marker. Troponin is the main marker for MI, myocardial infarction. Troponin is the main factor for MI, myocardial infarction. For example, when you go to the hospital and want to know whether if someone has an MI or not, you should check his or her troponin in a test named troponin. So troponin will use to find out whether MI happened or not. Do you understand? Do you know what is MI?
Yeah, after.
Heart attack or myocardial infarction. Enzyme. We have, I can see that more than 99% of enzymes have a protein structure. Just a very small group of enzymes are not proteins. And they have RNA-like structure. We name those enzymes as RNA enzymes. I will explain more in the RNA part of our class. So, the majority of enzymes are protein, except for a very small group of enzymes which has RNA-like structure. There are some examples of enzymes: trypsin, pepsin, DNA polymerase, and so on. Hormones. Some hormones are protein. For example, glucagon, gastrin, insulin. Proteins are involved in signaling pathways. Signaling molecules are protein. For example, adenylate cyclase, annexin. As I said, all antibodies are proteins, immunoglobulin. Fluid balance. Proteins are involved in fluid balance. For example, albumin involved in fluid balance. Vasopressin involved in fluid balance. Give you an example. I'm sure that you see some person with a very big abdomen and very thin body. Big abdomen with a thin body. Why such situation will happen? In our vein, we have albumin protein. When blood stream in our vein, by the pressure of our heart, pompage of our heart, this pump is so strong and can move out water in our bloodstream. However, albumin and other proteins still remains in our blood because they are so big. The size of proteins are so big. So they can't move out from our weight. Therefore, they remain in our bloodstream. When this water removed from our blood accumulate in tissue. However, because of albumin, this water can further turn to our bloodstream because albumin absorbs like a sponge. Albumin, like a sponge, absorbs the water to our bloodstream. Do you understand? So, if our albumin concentration will decrease, therefore, water cannot come back to our bloodstream and remain in our tissues. So water accumulates in our tissue and cause a situation named ascites, which is the accumulation of water in abdomen, in our abdomen. Acids, or acidic fluid. So acidic fluid is a fluid or water of our acid, and acid is the accumulation of water in our abdomen, in our patient abdomen. And what is the problem for happening of acids? Decrease the concentration of albumin in our body. You may ask that what is the reason? What are the reasons for decrease of albumin in our body? As I told you, the main place for producing albumin is liver. So, if our patients suffer to a liver disease, the concentration of albumin will decrease. There are too many liver diseases that cause such situation. For example, all hepatitis. Hepatitis can lead to this situation. Some cancerous patients, which under chemotherapy will suffer to such situation. Those patients have a very low concentration of albumin. So we need to give them albumin by injection before starting chemotherapy. You should give your patient albumin by injection to increase albumin level and then start chemotherapy process. Why do you need to increase the level of albumin in these patients? Why this patient needs albumin? Other reasons?
Why do you want to?
Why patient under chemotherapy needs albumin?
Transporting the things, the ions and
Transporting the chemotherapy drugs.
yes.
For transport chemotherapy drugs for all tissues, they need albumin. However, the level of albumin in this patient is low. So we need to increase the level of albumin and then give them the chemotherapy drug. Do you understand? Are involved in acid-base balance because plasma proteins and amino acids, also hemoglobin, are buffers. Like plasma proteins, amino acids, for example, hemoglobins and other amino acids are buffers. I explained in detail in our last session about the buffering reaction of amino acids. So they can involve in acid-base balance. And the last, but not the final example and function of these amino acids and proteins, especially proteins, is that they are channels and pumps. We have one important, the most important pump in our body is NAKATPase, which really important for our body.
Is it in the membrane of the cell?
Yes, yes.
Yeah.
This is located
Yes.
and at the membrane at the surface.
So you have to, potassium to go inside and sodium to the outside.
Very
Yeah.
good.
So
Very good. And very important for our heart muscle and other muscle, especially for our heart. The bone is too important, especially for our heart function. We have also other proteins, for example, band-3 protein. Band-3 protein is a protein which is located at the surface of RBCs, red blood cells. I explained a very important buffer in our blood, which is bicarbonic acid buffer. Each buffer reaction has two sides. The first one is acid, our acid, and the second one is conjugated base. Conjugated base. This is the very important buffer in our body. The production of these side molecules, our base, RCO3, will happen in RBCs. This reaction will happen in our RBCs. We need, RBCs need a protein, an enzyme named carbonic anhydrase for this reaction. Carbonic anhydrase needs a coenzyme, and it is Zn power positive 2, power plus 2. Carbonic anhydrase is an enzyme which catalyzes this reaction in our RBCs and needs Zn for this reaction. Oh. Zinc. HCO3 should move up in our RBC. move out in our RBC to our blood. For this, we need band 3. So, the moving out function of our RBCs will done by band 3 protein in RBCs, which exert HCO3 to our blood and to use for as a buffer. You can see some diseases, some examples of diseases which involve in proteins. For example, Alzheimer's disease caused by amyloid misfunction. Parkinson's disease caused by alpha-synuclein misfunction. All of these examples are proteins. And if this protein cannot work properly, this disease will happen. Other example, sickle cell anemia, which is main function of our hemoglobin, and so on. We have 4 structural levels for proteins. The first, the primary structure of our proteins is defined as the sequence of amino acids linked together. So, if several amino acids join together, link together, we have the primary structure of of proteins. So, the primary structure of proteins is linking several amino acids to each other by a linkage, a bond named peptide bond. Peptide bond. So, the linkage or bond between 2 amino acids is peptide bond. The linkage between 2 amino acids is a peptide. The linkage between 2 water molecules is hydrogen. The linkage between 2 monosaccharides, glycoside bound, O-glycoside bound. The linkage between 2 amino acids is peptide bond. Peptide bond. You can see what happened with a peptide bond will produce. Please look at the picture. When 2 amino acids, please be quiet. When 2 amino acids want to join to each other, these 2 functionalities bond to each other, and 1 water molecule will remove from the final molecule. So we have such molecules. This is peptide bond. This is the peptide bond. This is the peptide bond between 2 amino acids. So, the question will be, what is the primary structure of amino acid? The answer will be the linking between several amino acids will produce primary structure of proteins. The other question will be, what is the main bond? Will produce the primary structure, peptide bond. Secondary structure is the spatial conformation. Spatial conformation of polypeptide backbone. Spatial conformation of polypeptide backbone. So, when several amino acids link to each other, they can form several structural forms. We have three main secondary structures. Three main secondary structures. The first one is a helix. Helix. This is a helix, and name alpha helix. The second one is like a sheet. Warak. Sheet. And we named it beta sheet. So, alpha helix and beta sheets are two main secondary structures of proteins. Again, beta sheets and alpha helix and beta sheets are two main secondary structure of proteins. What are the linkage and bond for secondary structure? As far as I remember, I explained in detail what are hydrogen bonds, and you are completely aware and know about hydrogen bonds. So, the main bond which stabilize secondary structure of proteins are hydrogen bonds. Please write this point. The main bond which stabilize secondary structure are hydrogen bonds. So, the points are, the secondary structure exists in two or more forms. The first one are alpha helix, the next is beta sheets. The stabilizing bond for secondary structure are hydrogen bond. Very good. Easy, huh? Good. What are the main differences between alpha helix and beta sheets? Alpha helix will produce between polypeptide from just one chain. However, beta sheets can produce from several polypeptide chains. For example, one polypeptide can produce here, and you can continue other chain at the next, at the contrast side. So, however, for alpha helix, you should have a continuously structure. But for beta sheet, you can cut the structure and continue in other side, in other form. Alpha helix form a entirely coiled structure, form a fully extended structure. As I explained, and you can see in this picture, alpha helix like a coil. I don't know what you can say in Arabic. Coil, pitch.
مرتوي مرتوي لا ولا مرتوي دوار
I think so. I think so. So, alpha helix is like a super coil. How, like a coil. However, beta sheets
Twisted.
are not. They are like a sheet, like a plate.
خلاص
As I told, the hydrogen bonds are the main stabilizing bond in all proteins, in our structure. Also, when you stay your hand, your right hand, in this shape, and try to turn your fingers, such round shape is right hand, is named right hand, because our fingers tend to right. However, for left hand, when you try to turn your fingers, the side of your fingers are leftward, to the left. For right hand, to the right. For your left hand, to the left. Alpha helix. All alpha helix structure are right hand. All alpha helix structure are right hand. I mean, when they coil, they turn toward right. And the main and very important, please take your attention to this part of this slide, the fifth one. What are the main amino acids for alpha helix and beta sheets? If we have methionine, alanine, leucine, glutamic acid, and lysine, we will have alpha helix. However, if we have, let me magnify the picture. If we have isoleucine, valine, threonine, phenylalanine, and tyrosine, so we have beta sheet. Do you understand? Again, you can see alpha helix, which are right hand. Let the picture, right hand. Those are R groups. And you can see hydrogen bond between amino acids in alpha helix. Also, you can see hydrogen bond between beta sheets. Hydrogen bond between beta sheets. And the other secondary structure of beta term, which will happen when two chain of beta sheets will exist. When we have two chain of beta sheets, we need to attach and join these two chains. The attachment structure, the joinment structure of beta terms, which will happen when we have two beta sheets and want to join them to each other, like a glue, like a glue. We want to join them, and we need two beta terms to joining those beta sheet structure. The point is, what are the main amino acids in beta term? Proline, glycine. Proline, glycine. The tertiary structure of proteins is very important because now we have three-dimensional structure when tertiary structure will produce, then we have three-dimensional arrangement. We have an arrangement in space, three-dimensional structure. So the question is, which of the structural form of protein have three-dimensional structure? The tertiary. Of course, the other structure, quaternary structure, also has tertiary structure. So, when we have tertiary structure, we have three-dimensional structure. When we have quaternary structure, we have 3D structure. The point is, what is the stabilizing? What are the stabilizing interaction or bond for this structure? And as you can see here, hydrophilic, hydrogen bond, ionic bond interaction are the main stabilizing interaction for tertiary form. So, what are the main interaction which stabilize tertiary structure? Ionic bond, hydrophilic bond, and hydrogen bond. Three. For secondary structure, we have just hydrogen. For primary structure, peptide. Really? The question is very easy. We have two types of tertiary structure. Some proteins are fibrous proteins, and some others are globular proteins. So we have some fibrous protein and globular. There are two main classes of protein tertiary structure. Fibrous protein are generally composed of long and narrow strand. Long and narrow strand, like this one, like this marker. Long and narrow. However, for other one, globular structure, globular protein, have more compact and rounded shape. Compact and rounded shape. Round shape. They are like string. The first one, fibrous protein, are like string. نخ.
خيط.
And the other one, like a ball. Compact, yeah. Well, you can take your attention to this table, which is about the main differences between fibrous and globular protein. About shape, fibrous protein are long and narrow, however, globular are round and spherical. Purpose, fibrous protein are structural, however, globular protein are functional. For example, albumin is a globular protein. Albumin is a globular protein, but for example, something like proteins for our ingestion system are structured protein. Acid sequence, amino acid sequence, sorry. For globular, we have irregular amino acid sequence. However, for fibrous, we have repetitive amino acid sequences, which means we have a repetition in amino acids in fibrous protein. However, for globular proteins, we have different types of amino acid, various types of amino acid. Do you understand the point? The other. Fibrous protein are less sensitive to change in pH, temperature, and etc. However, globular proteins are more sensitive to change in pH and example like collagen, myosin, and for this one enzyme hemoglobin. Solubility. They are insoluble in water. However, these type of proteins, globular proteins, are soluble in water. Soluble in not all of them, but most of them. Not all, generally. Okay. And finally, the quaternary structure of proteins will happen when we have more than one chain of protein. When we have more than one chain of proteins. For example, hemoglobin has 4 polypeptides. 4 polypeptides. Hemoglobin, HB, hemoglobin has 4 polypeptides. 2 alpha and 2 beta. So, hemoglobin has quaternary structure. Myoglobin, on the other hand, has just 1 polypeptide. So, myoglobin has only third structure, tertiary structure. So, proteins who have more than 1 polypeptide give the quaternary structure, but protein which has just 1 polypeptide give tertiary structure. For example, myoglobin and hemoglobin. You can see an example here. There is a tertiary structure and there is a quaternary structure. So the quaternary structure of the protein is the association of several protein chains or subunits to a closely packed arrangement. Each of the subunits has its own primary, secondary, and tertiary structure. The subunits are held together by hydrogen bond and van der Waals forces. So the point is, what are the main interaction which stabilize quaternary structure? Hydrogen bond, van der Waals forces. When the quaternary structure exists, so we have more than one polypeptide. But what happens when a protein folds? I mean, let me give you an example. Here is a very good picture, image. Please take attention, it is very important here. This is a flexible polypeptide. You can change the shape of this polypeptide whatever you want. However, just one shape can work properly. Other shapes cannot work in a good manner. Just one of the shape that you produce will work properly as a target protein. Other shapes do not. So, you need to produce the correct protein. But how a cell determines which form of protein is better for the cell? We have some helpers in our cell to produce the main form, the best form of a protein. We have some helper in our cell that can help us to produce the best form of protein. I can see them here. Okay, you can write here. one of the main of these helpers are chaperones. Chaperones. Please write it. Chaperones. Chaperones are some proteins that can help our cell to produce native proteins, not other shapes, which are not good. Okay. Maybe you ask me what happened when a misfolded protein will produce. There are too many diseases, too many disorders related to misfolded proteins. Misfolded proteins. One of them was very famous, and that is perionic disease. Perionic disease. Does anyone know what are perionic disease? I think your age cannot help you about such diseases because such disorders were happened too many years ago. There are some animals, for example, sheep and cows, that act very amazingly. For example, they turn around themselves. They turn around themselves. When scientists study their brain, they find a very amazing subject. Their mind was like a sponge. Sponge. Their mind were completely like a sponge. What happened for these animals? When we scientists studied more, they find out that the main reason for these diseases was protein. But why protein can cause such diseases? And more importantly, an ill animal can transfer disease to other animals. I mean, proteins like virus, protein like other infections. This is very amazing. The point was that such proteins didn't fold properly. Those proteins did not fold properly. They fold incorrectly. Incorrect folding lead to aggregation. When such aggregation happens in our mind, in our brain hurt in a very amazing manner. Our mind, our brain, turn to a sponge and have too many pores, manifest pores. Okay? So, there are several diseases caused by proteins, misfolding proteins. For example, periodic diseases. You understand the point? So, misfolding can lead to such as another example, Alzheimer's disease, Parkinson's disease, cystic fibrosis. Another example of such diseases. Just final slide. Final slide. Sorry. Proteins. When proteins produce, they can further denaturate, which means the non-covalent interaction destroyed and protein disfolded, denaturated, which means all quaternary, tertiary, and secondary structure will destroy. However, the primary structure will still remain. So the point is, when denaturation happens, all quaternary, tertiary, and secondary structure will destroy. However, just the primary structure will still remain, because the primary structure stabilizing bond are the peptide bond, which are covalent. However, for the other ones are non-covalent, which are not strong. The main example for such reaction are eggs, fried eggs, and white and yolk. When you cook egg, the reaction which happens is denaturation of proteins in the egg. So the egg proteins will denaturate it and produce fried egg for you. There are several chemicals and conditions that can denaturate proteins. For example, change pH, chemical activities, and also temperature. So temperature, pH, and several chemicals can lead to denaturation of proteins. If you have any question, I can.
Starting class में नहीं था